Hello everyone, let's continue with tutorial number 3. The first question is related to binomial distribution. Based on the records on a server, it was revealed that 2% of the messages arriving the server were corrupted. Assume X has a binomial distribution. So it's given to us that X has a binomial distribution and it indicates the number of corrupted messages. So X is related to number of corrupted messages. Calculate the following. Now we have 6 number of questions for this part. So the question, for example, number 1, the probability of receiving 2 corrupted messages among 5 messages. So we already know that we are talking about binomial distribution. And we know the probability of success. So here in the question also, they revealed us the number of total trials. So for binomial, the first thing you should notice is that what are the parameters in this binomial distribution? So based on the question number 1 and the given information, we know that the probability of success is 2%. And number of trial is 5. So this part I denoted for probability of success and this part as the number of trials. So in some books maybe they prefer to show n in the first component and probability of success in the second one, but let's continue with this format. And the thing I want you guys to notice is that I also mentioned about it in the lecture, that probability of success is not necessarily a good thing in nature. Like here we are talking about receiving corrupted messages. So of course receiving corrupted messages is not a good thing to happen. But we call it probability of success because that's the way we define it for our problem. So probability of success is not necessarily a positive or negative thing. It depends on our question. So we should be careful about that. Don't be confused about its name. So probability of success here is 2% for our binomial distribution, and total number of trials based on this question I understood this is 5. Now, the question is about the probability of receiving 2, exactly 2. So probability of X equal to 2. That's the question. So right after writing the probability and what is the question, we should notice that what is the distribution that we are talking about, and we know that this is binomial. So for binomial distribution, we should know about the pointwise probabilities, how we can calculate them. Do you remember the formula? Combination X out of N, probability of success, power X, Q, N minus X. And how to calculate Q? By 1 minus probability of success. So I want to solve it in 2 ways. One way is to use the calculations. The other way is by using the table. And for checking the answers from the table for both binomial and Poisson distribution, I'm going to record it in another video today. But first, we should know from which part of the table I'm looking for. So first, I will talk about these things in the following questions. And then in a separate video, I will explain how to find them from the table. Okay, so let's say in our first way, I want to calculate it using pointwise probability. So we have an equality here. This is good because based on this, I can easily use this formula. So what I will have is 2 out of 5 combination. P is 2%. Power, what is X? X is given here, right? Power 2. And here for Q, you should write 1 minus 2%, which is 98% power 5 minus 2. And you can easily calculate it and write the final answer. Okay, so here this part is combination, this part and this part. We are just powering one constant with another constant, so it's easy to find the final answer. So this is the first way. The second way we can solve it is by using the table. The thing you should notice is that for reading your answer from the table, everything should be in the cumulative format. It means that you should have such a format like px less than or equal a value. Okay, so less than equal. This one is not necessarily equal to x, just less than a value. Okay, we should be careful about that because we are talking about discrete distributions. In discrete distributions, each one of the point could have a probability. But in case of continuous ones, doesn't matter whether you write less than equal or just less than. And we will talk about in details when we talk about continuous distributions. And we should notice this because it will totally affect our calculations. So I should somehow translate everything into this format. Now, here we have only x equal to 2. How to change it? So let me show you. To convert it to cumulative format, I can write this one as probability of x less than equal 2 minus probability of, just go one lag before. It means that x less than equal 1. Okay, so by using this trick, you can easily read both of them from the table. So the information of this one is known on the table and also this one, and you can find the final answer without using this formula. So that's the beauty of using the table, but we should know how to convert everything into such formats like less than equal value. If, for example, this is x less than 1, you cannot directly read it from the table. If it is x equal to 1, you cannot read from the table. Everything should be in terms of less than or equal, okay? Because this is a table provided in cumulative format. So in a separate video, as I said, I will show you how to read each one of them. And whenever you reach, for example, such format, you should take a look at the probability of success as n, as we talk about it in the lecture. Okay, for item number 2, the probability of receiving less than 2 corrupted messages among 5. Less than 2. I'm not going to write the formula again and the binomial distribution, but remember, whenever we ask you about such questions, provide us the binomial distribution, exactly what is that, and the formula when you want to use these calculations. Okay, here we asked you what's the probability of less than 2. We didn't say less than or equal. So we should be careful that this one is different from the cumulative version. Okay, let's say I want to use calculations. If that's the case, I can consider it pointwise, like remembering from the table, we have 0, 1, 2, and we have a maximum value because we tried in 5 trials. Okay, so we have an upper bound for it. I know everything will stop here because after going forward from that point, every probability would be 0. So when I ask you what's the probability of less than 2, only in these 2 points I may have some probabilities, okay? So I don't know exactly where I should put these points. Maybe this one is here, maybe for 1 this is here, so we should calculate it. So for this one, I can write pointwise x equal to 0 plus x equal to 1. So as you can see, whenever you want to calculate it, everything should be in format of equality so that we calculate them pointwise. So let me write just once more the formula so that you see. So out of 5, I'm taking now 0. Probability of success is still the same as our assumption, which is 2%, power 0, 98%, power 5 minus 0, which is 5, plus, I write the rest of it here, combination 1 out of 5, 2%, and this part should be 1 now, right? 98%, 4. And then you calculate the addition and find the final answer. So this is the way to solve it using pointwise calculations. Another way to solve it is using the table. But here, as you can see, this is less than, not less than equal. How to write it? So to write it in cumulative format, can you guess how can I write it? I should consider both 0 and 1. So I can write x less than equal 1, you see? So easily now you can read it from the table. So in the exam, if we don't specify which method to use, either calculation or table, you can use the one that you are comfortable with. But if you ask you use the table, then you should exactly use the table. Or if you say use the formula, then you should use the formula. So we should know both of them in order to solve such problems. Okay, next one, the probability of receiving more than 3 corrupted messages. The probability of receiving more than 3 messages. So again, in our graph, you don't need to show on the graph, but I'm just showing it so that it will be easily seen here. But for your solution, you don't even need such graphs. So again, I'm talking about 5 messages. The total number of trials here is 5. If we change that, the value of n inside the parameter of binomial distribution can change. We should be also careful about that. If here, for example, we have given 4, then we should take a look at another binomial distribution with n equal to 4, for example, okay? But here, in this case, n is equal to 5. Now, more than 3, it means that not 3 itself. As you can see, I don't fill inside this circle, and you should know such representation from calculus, hopefully. And until infinity. But I know there is an upper bound here until 5, so from 6, 7, 8, then we don't have probability, so we consider that 0. The probability would be equal to 0 from that point. So this point and this point, between them, we know that there are gaps and there are 0 as well. So all we have are these points, so we should calculate them. So you can write here x equal to 4 plus x equal to 5 and use the formula again. And again, by calculating it, you will provide the final answer, okay? So again, I use this notation for you to complete it. It doesn't mean that it's already done. Like previous ones, you should write the formulas for each one of them. You see it has 2 parts, this part and this part, and then write the final answer. Okay, and by the way, about the table, how to solve this question using the table only. So everything should be in format of less than or equal, how to convert it. Now we are talking about more than. So what you can do is that, first of all, x more than 3. I'm looking for this part. but I want to write everything in terms of less than equal. So by considering this part, how can I find about the complement of that? We already know that the probability of the sample space is equal to 1. We showed it before. Probability of omega is equal to 1. So 1 minus the complement of this probability. What's the complement? You change the direction of inequality. So this is more than, change it to less than. And whenever it doesn't have equality here, it should have equality here. And whenever it does have an inequality, you shouldn't have inequality in this part. Okay, we should be careful about that. So here, it's very easy now to read this part from the table and find the final answer. Okay, so with these things, it needs practice, but they are very easy. And whenever you have questions also, please let me know using email or office hours. Now, the probability of receiving not more than 2 corrupted messages, again among 5 messages. Not more than 2. So we are asking from a complement from the beginning. You see, not more than 2. It means that now you know how to write the complement. You can write, you can change the direction of inequality, change it more than to less than, and it doesn't have equality, it means that it should have equality here. So not more than 2, it means that less than or equal to. Great. Now, if you want to use the formula, it means that you should write here like this, pointwise. The formula can only work pointwise, okay? So the rest of it I write here, equal to 1 plus probability of x equal to 2. So for each one of them, you write the formula and write the final answer here. Now, what about reading from the table? So I already understood I can use this one, right? So 1 minus probability of x more than 2 is equal to x less than or equal to. So whenever we have less than or equal, directly you can read it from the table. Perfect. So you see, sometimes it's easier to use the table. Sometimes it's easier to use the calculation. But as I said, in the exam, we should be careful which one of them we are asking. If we didn't specify, you can use each one of them, which is more comfortable for you, and you can easily find the final answer. Okay, we can also ask questions like, what's the expected value of x? Sorry. For this one, you should know about the formula. When we talk about binomial distribution, then it can be calculated using NP. So you should know about the parameters. So the total number of trials should be either given to you in the question from the first part or this part. Okay, so you already know the probability of success is equal to 2% and n is equal to 5. So 5 multiply p, which is 2%, is the answer. Okay, so as you know, 1% will be the, 10% will be the final answer. And what about variance of x? So these kind of questions can be very easy if you have the formula. So since we are dealing with open book exam for both midterm and final, it should be very easy for you anyway because the formulas are given. Just provide us the formulas for sure so that we know when you are assigning the values to which exactly variables you are assigning. So whenever we ask you any questions, please provide all the formulas, all assigning values as the complete solution. So here n is equal to 5, p is equal to 2%, and Q is equal to 98%, and you can find the final answer. For these two, it's not necessary that you find the answer between 0 and 1. It could be any values, right? Even for expected values, it's possible to find negative values. But for variance, you should be careful that it's always less than or equal to 0, okay? Because if you pay attention to the formula of variance, it has power 2 inside it, and we get the summation of them. So it never gives you a negative value at the end of it. But for mean of a variable, random variable, this is possible. Okay, guys, I will continue the second question in the next video.